There's not much algebra in D2, although there's a lot of stuff. But only 2 bullet points, and one of them is this, the mass luminosity relation. L proportional m to the 3.5. So let's give that a try. Firstly, it only applies to main sequence stars. You've just got to remember that. It's not in the data booklet. I mean, that is on its own, but it doesn't say it only applies to main sequence stars. If they tell you a main sequence star, start giving this sort of data, then that's your clue to use this. They could give you other relations like that, but this one is specific to main sequence stars. So think what it means. Generally, the more massive a star, the more luminous it is, which should make sense, but mass makes a big difference. So if it's m to the 3.5, think about that. That means if we double the mass, how much more luminous is it? Well, it's 11.3 times the luminosity. So double the mass, you'd think that means it would have double the fuel, and therefore perhaps burn twice as brightly, or be twice as luminous, but it's not. It's 11 times as brightly, because the core is bigger, and the core can burn more quickly. It can fuse hydrogen more quickly. It's denser. So it makes a big difference. So let's try this. These things, it looks simple, but it can be tricky. Suppose the question is, if we have a star with twice the luminosity of the sun, what's its mass in terms of the mass of the sun? So to be twice as luminous, it must be a bit more massive. Doesn't need to be twice as massive, so 1 point something is the kind of answer we want. So a couple of ways to do this, depends how you do your proportionalities, but please work this through. Please get comfortable with this. So here's how I would do it. If L is proportional to m to the 3.5, then L over L is equal to m over m to the 3.5. Of course, we can't just say L over L. Let's compare this to the sun. Shouldn't put that outside the brackets, really. Compare this to the sun. So I want the mass of something. I've just said its mass is twice that of the sun. So this side of the equation is 2. So that's m to the 3.5 over m sun to the 3.5. So really I want that ratio there, m over m sun to the 3.5, which means that m must equal, so take this over, how do I invert this function here? That's 2 to the power of 1 over 3.5, and that's 7 over 2, so it's 2 over 7. That's m over m sun, so just multiply by m sun here. That was the tricky bit. So you've got to invert that, that fractional index. Turns out 2 to the power of 2/7 is about 1.22. So it's 2 squared, 4, and then the 7th root of that. So 1.22 m sun. So if it was 22% more massive, our sun will be twice as luminous. Imagine that.